Hello everyone. In this video, we are gonna learn how to identify functional groups in organic molecules. Functional groups are a specific group of atoms within molecules that are responsible for the characteristic chemical reaction of those molecules. Identification of the functional groups helps us to understand the behavior and properties of organic compounds. Functional groups define how a molecule reacts in chemical reactions, influencing its behavior and interactions. They help to classify compounds into families such as alcohols, ketones, and carboxylic acids, each with unique properties. Knowing the functional groups allows chemists to predict how molecules will behave in various reactions and processes. Understanding of functional groups support in designing synthetic pathways and applying compounds in industry, medicine, and research. They affect physical properties such as solubility, boiling point, melting point, and polarity. Before diving into the functional group problems, let's first review the functional groups that can be tricky and confusing. At first glance, some may seem similar, but a closer analysis reveals their distinct differences. Understanding these nuances will help clarify any confusion during exams. Let's start with these two functional groups. The first one has an OH group, making it an alcohol. The second also has an OH group, but here it is attached to the carbonyl carbon. The OH is next to the carbonyl group. When an OH and carbonyl groups together, they form a carboxylic acid functional group. Here are two similar groups. Both have carbonyl groups, but they differ in their attachments. In the first case, the carbonyl group is bonded to carbon on one side and hydrogen on the other side, making it an aldehyde. In the second case, the carbonyl group is bonded to carbon on both the sides, making it a ketone. Carbonyl with hydrogen on one side is an aldehyde. Carbonyl with carbon on both sides is a ketone. This one is an alcohol, as we discussed earlier. This is also an alcohol. But if the OH group is present on the benzene, it is directly attached to a benzene ring. It's specifically called a phenol. The next two are often confusing and commonly mixed up. In the first case, oxygen is single bonded to the carbon on both sides, which define it as an ether functional group. In the second case, oxygen is also single bonded to the carbon on both sides, but this oxygen is attached to carbonyl carbon. The oxygen is next to the carbonyl group. When oxygen and carbonyl group are together and their next neighbors are carbon, then this one is known as ester functional group. Since ether and ester sound similar, it's important to pay close attention to their structures. Similar to the confusion between ether and ester, these two functional groups can also be quite tricky. An NH2 group is an amine. However, if the NH2 group is next to the carbonyl carbon, it forms an amide. So while an amine consists solely of amino group, an amide contains both NH2 and a carbonyl group. Now let's identify the functional group in a few common organic molecules. The first molecule is cinnamaldehyde. The flavor and odor in cinnamon spice is because of this organic molecule. Cinnamaldehyde is having antimicrobial and anti-inflammatory properties. The first functional group that I have highlighted in this molecule is having a carbonyl group, and the carbonyl group carbon is attached to carbon on one side and hydrogen on another side. Carbonyl with hydrogen on one side is an aldehyde functional group. This aldehyde functional group is attached to carbon-carbon double bond. So this functional group is an alkene functional group. Next to alkene, we have a six-membered carbon ring having single and double bond alternate. So this is your benzene. But if we want to be more specific, then we will say that it's a phenyl ring. In benzene, if one of the hydrogen is substituted by another group, then it is known as phenyl ring. In this benzene, the hydrogen of this carbon is substituted by carbon-carbon double bond, so we can say that this is a phenyl ring. This is gingerol. Gingerol is found in ginger and has antioxidant and anti-inflammatory properties that can support digestive health and reduce nausea. The first functional group highlighted here is OH, and OH is an alcohol. There are three types of alcohol: primary, secondary, and tertiary. So let's try to find out this alcohol is of which type. The carbon holding the OH is attached to two carbon. So this is an example of secondary alcohol. Next we have a carbonyl group, and this carbonyl group is attached to two carbon. So this is a ketone. Here we have oxygen that is single bonded to carbon on both the side, and this is ether. Next we have an OH group, but this OH group is present on the benzene ring, so we will say that it's a phenol. So in gingerol we have secondary alcohol, ketone, ether, and phenol functional group. This is thyroxine, a hormone produced by the thyroid gland. It regulates metabolism, growth, and energy level in the body. In thyroxine molecule, there is one functional group that is repeated 4 times. Iodo is a halide, so we can say that we have alkyl halides. There is a carbonyl group, but this carbonyl group is attached to OH. Carbonyl and OH together is carboxylic acid. We have NH2 group. NH2 is amine. But similar to alcohol, amines are of three types: primary, secondary, and tertiary. Nitrogen of amine is attached to one carbon. It is having one carbon as his first neighbor. So this is an example of primary amine. Six-membered ring, single double bond alternate. This is benzene. Oxygen having carbon on both the side with single bond makes it an ether. OH group attached to benzene ring is phenol. Next molecule is aspirin. Aspirin is a non-steroidal anti-inflammatory drug, also used as a blood thinner. This functional group is having a carbonyl group, and next to it we have an oxygen with the single bond. Carbonyl with oxygen and carbon on both the side is an ester functional group. There is one more carbonyl group, but this carbonyl group is having OH next to it, so this is your carboxylic acid. Then we have a six-membered ring, that is benzene. Aspirin is having ester, carboxylic acid, and benzene functional group. This molecule is acetaminophen, also known as paracetamol or Tylenol. It's a non-opioid analgesic and antipyretic agent. There are two functional groups. There is a carbonyl group, but this carbonyl group is next to the NH group. Carbonyl along with the NH group is known as amide. And we have a OH group. This OH group is present on the benzene, so this is your phenol. So acetaminophen is having two functional groups, that is phenol and amide. This molecule is albuterol. It's a drug used for asthma and bronchitis treatment. In albuterol, we have NH group, so we have amine. Nitrogen of amine is attached to 2 carbon. First neighbor is 2 carbon. So this is an example of secondary amine. Next we have OH group. So this is an alcohol. Carbon holding the OH group is attached to 2 carbon, so this is your secondary alcohol. We have one more OH, so we have alcohol. Carbon holding the OH is attached to 1 carbon, so this one is your primary alcohol. OH, but this OH is directly attached to the benzene ring, so we have phenol. Don't get confused between this one and this alcohol, because in phenol OH is directly attached to the benzene ring, whereas in this case there is 1 carbon in between, so this one will not be known as phenol. This is your primary alcohol. This molecule is amlodipine, used to treat high blood pressure. We have chloro group, so this is an example of alkyl halide. But as you can see, chloro is attached to the benzene ring. So if we want to be more specific, then this is an aryl halide. We have NH group, that means we have amine. We have NH2, this is also amine. Nitrogen of amine is attached to 1 carbon, so this is an example of primary amine. We have a benzene ring. We have oxygen, and this oxygen is single bonded to carbon on both the sides, so this makes it an ether. We have a carbonyl group, and carbonyl group is attached to oxygen, and we have carbon on both the sides, so this is an ester. The similar group we have on the right side as well, carbonyl with oxygen, so we have one more ester functional group in amlodipine. This molecule is raloxifene, which is a non-steroidal selective estrogen receptor modulator used to treat postmenopausal osteoporosis. I have circled all the functional group in this molecule. I would suggest you to pause the video for a few minutes and try to identify the functional group by yourself. Here we have nitrogen, that means we have amine, but this nitrogen is directly attached to 3 carbon. So that means this is an example of tertiary amine. Next we have oxygen, and oxygen is single bonded to carbon on both the sides, that means it's an ether. We have a 6-membered carbon ring with alternate sigma and pi bonds, so we have benzene. Next we have a carbonyl group, but this carbonyl group is attached with carbon on both the sides, so this is your ketone. We have a OH group. OH group is directly attached to the benzene ring, so this one is your phenol. We have a sulfur attached to the carbon on both the sides, similar to ether, but we have a sulfur here, so this is known as thioether. We have again OH group attached to the benzene ring, so we have phenol functional group. Thanks for watching. I hope this video clarified how to identify different functional groups in organic molecules. Remember, practice is key to mastering these concepts. So keep working through problems and reviewing the structures. If you have any questions or need further clarification, feel free to leave a comment. Don't forget to like, share, and subscribe the channel. Happy studying.